looking at section 7.3, we're going in the opposite direction of what we did in 7.2. So we're looking at how can we show that something is a parallelogram. So our essential question, how can you prove that a quadrilateral is a parallelogram? Most of these will be very closely related to what we looked at yesterday. Our first one, if both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. That's basically our definition of a parallelogram. Our reason for that we would use if we're saying how do we know this, would be opposite sides parallel. Our second reason, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Okay, which is the converse of our first theorem from yesterday. Okay, and again, our statement there would be opposite sides are congruent. Our third one, if both pairs of opposite angles are congruent, that is a parallelogram. And our reason there is opposite angles are congruent, but realize it has to be both of them. So if we have, in this picture, we have A opposite C and B opposite D. So if I know B is congruent to D, but I don't know anything about A and C, I can't say it's a parallelogram. Our fourth one, right, is a little bit different than what we did yesterday. It's sort of combining a couple things. It says if one pair of opposite sides are both congruent and parallel, then the quadrilateral is a parallelogram. Right? So I need one pair of sides, need them to be both congruent and parallel. And then markings on the other one does not matter. So here we have BC and AD congruent by the line and parallel by the angle. So that would be a parallelogram. And my reason would be opposite sides congruent and parallel. And then our fifth reason is if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. Oops, which you can't see because I didn't move it up. There we go. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. And so again, I need both pairs, right? But this is the converse of our last theorem from yesterday, right? And our reason there would be diagonals bisect each other. So looking at some of our problems, right? One of the things we'll see is I'm asking, is this a parallelogram? How do I know it's a parallelogram? So example one, what theorem can you use to prove that the quadrilateral is a parallelogram? Right, so this goes to the theorems we just looked at. So A, I have opposite sides congruent, and that would be my reasoning. Opposite sides congruent. Right. B, I have one pair of opposite sides congruent and parallel. So I have opposite sides congruent and parallel. C, could actually do two things here. The most obvious is probably that opposite angles are congruent. Right? Because they give me the measurement, if I add these, I get 180. If I add these, I get 180. That means my opposite sides are parallel, right? Based on our consecutive interior angles. So I could use that as well. And then D, diagonals bisect each other. So the only one we didn't use there is the opposite sides parallel, which again we said we could have used on D if we wanted to. Example 2, I'm looking at a similar thing, but a little bit more complicated. It says describe how to prove that ABCD is a parallelogram. So start by looking at what they give me. They give me that AD is congruent to BC. Right? So I have one pair of sides congruent. They also give me a diagonal and two angles. Those angles are alternate interior angles. So I also know that AD is parallel to BC. So then my reasoning would be opposite sides congruent and parallel. We can also solve problems here. Solving problems is basically the same thing as yesterday. The difference is they're going to say what value makes it a parallelogram. Instead of it is a parallelogram, what's the number have to be? All right. So I have 5x and 2x plus 9. So the diagonal is bisected. So 5x equals 2x plus 9. Subtract 2x from both sides and divide by 3, and I get x is 3. Then in B, and with angles, watch what they're giving you. These are consecutive angles, so these add up to 180. Right? So I have x plus 10 plus 2x plus 20 equals 180. Okay. Combine like terms. So I have 3x plus 30 equals 180. Subtract the 30 from both sides. We'll have 3x equals 150. Divide by 3, x is 50. Then if you'll turn the page, the last thing we want to look at is showing that a quadrilateral is a parallelogram. So we can use any of our theorems to do this. Generally, what we probably want to do is show that both pairs of sides are parallel unless they give me something easier. With the picture we're looking at here, to show that opposite sides are congruent, I would need to use distance formula 4 times, which we don't really want to do. Showing angles is hard. Showing diagonals bisect each other, I'd have to find the midpoint and then do distance formula 4 times. None of that is fun, right? But slope I can find just by counting, right? So I look at my different sides, right? So I have KL. We have KL and NM. All right, so I want KL to be parallel to MN. And if I count here, I go over 1, 2, up 1, 2. If I come here, I go over 1, 2, and up 1, 2. That means they both have a slope of 1, and I'm good, right? And then I want KN to be parallel to LM, right? So I look at those two. Here I come down 1, 2, 3, 4, and over 1, 2. Right? I do the same thing here. I come down 1, 2, 3, 4, and over 1, 2. So here I have a slope of -2. Right? So both things have the same slope. So then I showed it's parallel because opposite sides are parallel. Okay. If you had a picture where the lines were horizontal or vertical and they were easier to count, then maybe I want to use congruence. But generally, slope is going to be an easier thing to show because I can just count what I'm doing. And that is the lesson for 7.3, proving that quadrilateral is a parallelogram.